Well, good evening, class. Tonight we're going to be discussing lesson 2.2, and this is going to be on the distributive property. Okay, now I want you to think about, like we talked about the last properties, when we talked about commutative and associative, we talked about the root word. Well, I want you to think about the same thing here. The root of the distributive property is to distribute. Okay, so think about when you're sitting in a class and you're about to get papers, maybe a quiz or a test, and the teacher walks around and hands one copy of each of the quiz or the test to each student. Okay, the teacher is walking around distributing the papers. Okay, the same thing happens once the teacher has graded the papers. Again, the teacher will walk around the room and give one paper to each student. Well, that's basically what the distributive property is doing with numbers. Okay, so in the distributive property, let's start in the most general sense. Suppose we have any three numbers. I'm going to represent them with variables, and they could be variables as well, but basically any three things. And imagine that two of the things are added or subtracted inside of the parentheses, and the third number is outside, and it's times the entire quantity. Now, in order to evaluate this, like we've been talking about, you would have to know what all three of these numbers were, and then you'd have to follow the order of operations. And since there's a set of parentheses here, you would have to add the z and the y, whatever those happen to be. Then when you get that answer, you would then multiply that times x. Now, there are cases where you may not know what both of the variables are, both y and z. Like, I could give you a problem where I give you the value for x and the value for z, but not the value for y. And so, for a whole variety of reasons, it becomes really helpful to figure out another way around this. Okay, so order of operations says you have to do the parentheses first, followed by the multiplication. Well, what if that's not possible? Is there another way to do it? And the answer is yes. What we can do, since x is multiplied by the whole sum of y plus z, we can actually break this down and first multiply the x times the y, and then multiply the x times the z, and then add them together after the fact. So again, let's go back to the root word distribute. What's happening is the number that's outside the parentheses gets distributed to both of the things that are inside with the plus. So the x is multiplied times the y, and the x is multiplied by the z. Okay, let's try an example with a few less variables. So now let's put a 5 times the parentheses 2x minus 3. Okay, now we don't have a plus in the middle anymore, but we do have an addition subtraction inside of parentheses, and we don't know what x is yet, so we can't multiply. What we should do here is do the parentheses first, and inside the parentheses we have to take the x and multiply by 2, or double it, then subtract 3, take whatever answer comes out of that, and multiply by 5. Since we don't know what x is, we're going to use the distributive property, and we're going to multiply the 5 that's outside times both of the things inside. So 5 times 2x, well 5 times 2 is 10 x's, and 5 times negative 3 gives us a negative or a minus 15. And again, I've distributed the 5 to both the 2x and the negative 3. Now that's the distributive property. All right, so let's go ahead and practice a little bit of distributive property. So I'm going to write a couple examples down here. And what I'd like you to do is I'd like you to pause the video, copy down these 4 examples. You can do this on your notes section of your daily quiz log, or you can just do it on a regular sheet of paper. And I want you to try to distribute each of these. Okay, now there's some negative numbers. Be careful about those. Be especially careful about the bottom one. Excuse me. This negative out front is treated just like the one above it. It's treated like a negative 1, and it'll have to be distributed through. Okay, so take your best shot. These are pretty challenging. If you get frustrated or you get stuck, don't worry. Just go ahead and unpause the video, and we'll do them together. Okay, pause the video now and take your best shot at these 4, and we'll see how well you do. All right, well, you should have evaluated all 4 of these. And one thing I'd like you to do when you show your work is draw the little arrows here. Now this one, the first one, the number that's multiplied is actually on the right. That's okay. You're still going to do the same thing. You're going to multiply both of the things inside the parentheses by 2, so both the x and the negative 3. So 2 times x is just that, 2x, and 2 times a minus 3 will give us minus 6. Okay. The next one, I'm going to show you another little trick. When you have negatives, it's a really good idea to circle the negatives. So the minus x is treated like a negative x, and the negative 3 out front. And now we're going to draw the little arrows in, and you can either draw arcs or arrows, it doesn't matter. But that's what we're going to distribute on this one. And so negative 3 times 4 is negative 12, applying what we learned from chapter 1. And a negative 3 times a negative x. Well, let's see. If we're multiplying two things together that are both negative, they're the same sign, so we're not going to find their sum, but we are going to get a positive answer. The negatives are going to cancel out. So negative 3 and negative x multiply to give me plus 3x. Now if you want to rewrite that as 3x minus 12, you're welcome to do that. Essentially you're using the commutative property of addition to switch the 3x, oops, that doesn't look like a 12 anymore, and the negative 12. Okay, and a lot of people like to have positive things out front. They also like to have the variables out front and the constant term towards the end. All right, the next one, no different. Again, if you circle the negatives, it makes it a little easier. And what we're going to do on this one is all we're going to do is multiply through by a negative 1. That's going to change the first 2x to a negative 2x. And it's going to change the plus 3y to either plus a negative 3y or just minus 3y. Okay? And the last one, as I gave you a hint before we started, this is going to be treated just like a negative 1, the negative sign up front, and we're going to multiply it through and distribute it to both the 5x and the negative y. And so the negative 1 times the 5x will be negative 5x, and the negative 1 times the negative y will become plus y. Okay? And so you notice that as we distribute each of these numbers, I'll go ahead and circle the 2 as well. As you distributed each of the numbers that were outside the parentheses, we multiplied both of the terms inside the parentheses by that number. Okay, so a good example down here on the third problem, the negative 1 got multiplied by both the 2x and the 3y. Those are terms separated by the plus that were inside the parentheses, and each of them got multiplied by negative 1. Okay, so all of those are applications of the distributive property. This is going to be an amazingly useful concept, and that's why we're not doubling up any of these lessons. We really want to spend a day really practicing and getting good at the distributive property. All right, let's take another look ahead here. And let's look at a different way we can use the distributive property. Okay, so one of the reasons we need the distributive property is if we have variables and we can't do the parentheses ahead of time. But we can also use the distributive property to do mental math. Suppose I had to do 8 times 97. Now that's not a problem I can do in my head. I might be able to struggle through the carries and kind of picture it in my head, but it's a lot easier to do this one on paper, unless I use the distributive property. Now 97 is not a very nice number, but it's very close to a very nice compatible number 100. In fact, I could write 97 as 100 minus 3 and put parentheses around it. I think you can see that that's exactly the same thing as 97. And the 8 times would just go out front. Now what's the benefit of this? Well, let's do distributive property now. And I don't have much room on top, so I'm going to draw the arcs this time underneath. And 8 times 100 is 800. And I can do that in my head very easily. And 8 times negative 3 is negative 24. And now all I have to do is take 24 away from 800, which will leave me with 776. And so now, without any weird carries or writing down anything complicated, I've been able to do this problem mentally by applying the distributive property. Okay, that was not great, but let's go ahead and recopy that. 12 times 103, I can do the same thing here. I could technically rewrite either the 12 or the 103. I could change the 12 into 10 plus 2, but then I'm going to have to multiply by 103. Or I could change the 103 into 100 plus 3. And again, 12 times 100 is equal to 1200, or 1200, and 12 times 3 is 36, and I'm adding those together, and so I get 1236. Again, I'm able to do the math in my head because the distributive property allows me to simplify the problem. Now there's one more way to use the distributive property, and that's going the other direction. Okay? So here's two problems, And these problems have already had, like the first one has already had an 8 distributed. What if we go backwards and we undistribute that? It's called factoring. Let's take an 8 away from both this and this. And what I'll be left with is 27. The minus will still be there, and the 17 will still be there. Oops. Sorry about that. Okay. And now I only have numbers, so now I can kind of go backwards. Now I don't need the distributive property, and I'm actually better off by going ahead and evaluating the inside of the parentheses. 27 minus 17 gives me 10, and 8 times 10, again, is a simpler problem that I can now do in my head. The bottom one, both of the terms have a 17 in them. So if I take the 17 out front, I could rewrite this as 17 times, let's see, we got an x and a 23, and again we're adding, and we would simplify down to this. Now, you could argue which of these is better, but it is a skill, and it might be helpful to go in that direction. Again, this is using the distributive property in the other direction. Okay, that's pretty much all I have for you on the distributive property for tonight. If this is feeling a little bit unclear, you might want to go back and review a little bit, but otherwise, I will see you next time, and I hope you've enjoyed this lesson on the distributive property. Good night.